Okay, so now we're looking at a golf ball, and that means we're looking at a sphere. We're going to ignore all the little dimples in the golf ball because we don't have any information about those. So we've got a sphere and we have a cylinder. So let's start with finding the volume of a golf ball. I know from my formula booklet that the volume of a sphere is going to be 4/3 pi r cubed. So we've got 4/3 pi. Our r is going to be half of the diameter. So let's write that down first. So we know that r is going to be 3.4 divided by 2. That's going to give us 1.7. So volume 4/3 pi r cubed. And now I know that this 1.7 divided by 3, that's not going to give me an exact value. So right now I'm just going to put this whole thing into my calculator. 4/3 pi r cubed. All right, and I'll get about 20.6. And that's going to be centimeters cubed, cubic centimeters. But I am probably going to want to have this value for later. So right now, I'm just going to go ahead and store this as A. And I'm going to leave myself a hint that I've stored it as A. So store alpha A. All right, so now my calculator has that volume of the golf ball stored. All right, the volume of the hole that it's going to drop into, that's a cylinder. So I know that for a cylinder, let's see, the diameter is 4 times that of the golf ball. So diameter of the cylinder is equal to 4 times the diameter of the golf ball. So that's going to be exactly 4 times 3.4, 13.6. So that means the radius of the cylinder is going to be half of that. Okay, and I get 6.8. All right, so that allows me to calculate the volume if I also know its height. 3.8 times as deep. Well, if it's 3.8 times as deep, I know that the diameter, and this is also a diameter of my golf ball, so my height is going to be, the height of the cylinder is going to be 3.8 times the diameter. So let's work this one out. And even though I have more than 3 significant figures, this is an exact value, so I'm not going to round. So 12.92 centimeters, and I could even make a note saying that that's exact, so that the person marking my paper knows I haven't rounded. Now I can find the volume of the cylinder. Volume of a cylinder is pi r squared h. And now I'm going to round. So let's put that in. So pi r, wrong button, squared times my h, which was the 12.92. And I'm going to store this value as well because I'm probably going to need it. So I'm going to store that as B. And if I round to 3 significant figures, then I'm going to get about 1800. So this is going to make this round up. So 1880 centimeters cubed. All right. Find the surface area of the golf ball. Well, that's easy. That's just formula for surface area of a sphere. So surface area of a sphere, 4 pi r squared. 4 pi, the radius for my sphere was 1.7. And again, I'll give the approximate value for this. 4 pi 1.7 squared. And I want to make sure that I'm only squaring the 1.7, so I'm going to insert a multiplication sign there. All right, so we get 36.3 centimeters squared. Now we're talking about area, so here's my centimeters squared. All right, estimate how many golf balls will fit in the hole. So now I'm filling up the volume of the hole with my volume of golf balls. So I'm going to estimate that, I'm going to do volume of the cylinder divided by volume of the spheres to see how many fit in. So that was my B divided by A. And over here I stored this as B. So in my calculator, I'm going to do B divide by A. And so I get 91 golf balls will fit in. That seems like a very high number. But this is a very deep hole with its height being so far down. So I think this is okay. All right, so I'm going to get 91. That's a very, very high number. So let's just read this again. Diameter of 3.4. It has a diameter 4 times that of the golf ball and 3.8 times as deep. So 4 times that, divide by 2, gave us the radius. And then the height, 3.8 times 3.4. Yes, that makes sense as well. So this is going to be a very big number. 6.8 squared times 12.92 squared, 1.7 cubed. Well, that's like 2 cubed, which is about 8. 8 times 4 is 32. But then divide that, we get about 10. 10 times 3. Maybe this should be a little bit bigger, but not much. So let's just go make sure that we typed that in correctly. 4 divided by 3 times pi. And then times 1.7 cubed. Yep, we've got our correct answers. All right, so apparently 91 golf balls are fitting in that hole. That must be a very large hole that it's falling into. Estimated that on a particular course, 1 out of every 20,000 shots results in a hole-in-one. So 1 in 20,000 is a hole-in-one. At this rate, approximately how many people will have to play this hole in order for it to be filled only by holes-in-one? Well, we know we would need 91 people to win. So we would need 91 people to get holes-in-one. And if it takes 20,000 people to make 1 hole-in-one, so 20,000 people get 1 hole-in-one. I want 91 holes-in-one. So I'm going to need to take my 20,000 and multiply it by 91. So 20,000 times 91. I would need, let's see here, 1,820,000 people to play to fill the hole with holes-in-one.